Okay, notes 8.2, we're going to be looking at square root functions. On number 1, it says fill in the table and graph f of x equals square root of x. This is the square root parent function. So you will fill this in on your yellow parent function chart. So this is the square root parent function. Alright, so we are taking the square root of our x value. Okay, so let's think of something that we can, the smallest value we can plug in. So we can't plug any negatives in because when we take the square root of a negative number, it's an imaginary number. So the smallest would be 0. If we plug in a 0, the square root of 0 is 0. 2, or 1, if we plug in 1, square root of 1 is 1. If we plug in a 2, we can't take the square root of a 2 to get a whole number. Okay? So let's think of the next perfect square that we can plug in. So that would be 4. Square root of 4 is 2. And then the next one would be 9. Square root of 9 is 3. Okay, so let's go ahead and plot these points and see what a square root function looks like. 0, 0, 1, 1, 4, 2, and 9, 3. You're going to connect them, and then you have, it's continuous. We keep plotting points. Now, we can't keep plotting points to the negative side because we can't plug in a negative and take the square root of a negative number. So you'll have like a ray. It's an endpoint with a line on the end. Okay, so we'll have an endpoint on our square root graph. Notice it looks like half of a parabola on sideways. Okay, so this is a square root of x graph. The domain, if you look at the x-axis, it's everything greater than or equal to 0 because it won't include, we can't plug in any negative numbers in for x. The range, if you look at the y-axis, it's everything above 0 also. So y is greater than or equal to 0. Alright, so we're going to describe the transformation and then we're going to sketch the graph. So notice there's a negative in front of our square root of x, which is our parent function. So remember we talked about that on 8.1. That reflects it across the x-axis. Okay, so our 0, 0 point is not going to change because we're not shifting. We're just reflecting. Remember we talked about when you reflect it, you're just changing the signs of your original y values from your parent function. So instead of having 1, 1, we're going to have 1, negative 1. Instead of having 4, 2, we're going to have 4, negative 2. Instead of having 9, 3, we're going to have 9, negative 3. So it looks like that. Alright, let's take a look at 3. We have h of x equals square root of x plus 5. A square root is the same as having parentheses there whenever we're shifting. Okay, so if the number is under your square root, that is a horizontal shift. If it's x plus 5, that is doing the opposite, remember we talked about, so that's a shift to the left 5. Okay, so remember we talked about we're always shifting our 0, 0 point. So we do have a 0, 0 point on the square root of x. We're shifting it to the left 5. 1, 2, 3, 4, 5. So just like on the quadratic ones, that's our new origin. And I'm plotting the points for my parent function up at the top. So 1, 1, 4, 2, and 9, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 3. You have to know where your 0, 0 point shifted to know where to put your line at the end. So our transformations stay the same no matter what type of function we're looking at. It's still shifting the same way, it's still reflecting, it's still stretching, shrinking the same way. Okay, it's just a different function that we're having to translate. Alright, let's look at 4. Notice on this one we have the square root of x, which is our parent function, and then we're subtracting 8 on the outside. Same thing as on quadratic. If it's on the outside of the parentheses, then it's a vertical shift. So this is on the outside of our square root, so this will be down 8. So we're going to shift our 0, 0 point down 8. So there's our new endpoint of our square root graph. And then everything else stays the same. So 1, 1 from that new point, 4, 2, and 9, 3. Alright, so we're summarizing that. The negative reflects across the x-axis. If you have x plus h under your square root, that's a horizontal shift. If it's x plus h, that's shifting to the left, h units. And then x minus h is going to the right, h units. On the outside of the square root, if you're adding, that's shifting up, k units. And then the minus is shifting down. We haven't done an example today, but we will. You have an a. If a is greater than 1, just like on the quadratics, that's a stretch. And if a is in between 0 and 1, that's a shrink. Alright, now let's look at multiple transformations. So we have our parent function table here, f of x equals square root of x. Let's go ahead and plug in our values. So our values on the square root of x are 0, 0, 1, 1, 4, 2, and 9, 3. Alright, let's write our transformations down. The negative in front reflects it. Under your square root, you have x minus 3, which would be a shift to the right, 3. And then the plus 4, you're going up 4. So just like on your quadratics, we're shifting our 0, 0 point, and we're shifting that first. Then we can worry about the reflection or the stretch or shrink. So I'm going right 3, up 4. There's my new endpoint to my square root graph. And then we're reflecting, which means you're changing the sign of each one of your original y values. So instead of doing 1, 1, we're doing 1, negative 1 from that endpoint. 4, negative 2, and then the 9, 3, negative 3 goes off the graph. So it should be decreasing from left to right if it's a negative, increasing from left to right if it's a positive there. So in a parabola, it was opening up if it was positive, opening down if it was negative. Alright, domain, look at the x-axis. Look at that endpoint. That x value is 3, and it's everything to the right. So x would be greater than or equal to 3. If you look at the y-axis, that y value of that endpoint is 4, and it's everything below. So y is less than or equal to 4. Alright, let's look at 12. Filling in our parent function chart, 0, 0, 1, 1, 4, 2, and 9, 3. Okay, so notice the 2 in front will be a stretch by 2. X plus 1 under the square root is going to be going to the left. And then the minus 3 will be going down. So again, you're going ahead and shifting your 0, 0 point, then you can reflect, stretch, or shrink. So I'm shifting 0, 0, left 1, down 3. There's my new endpoint, also my new origin. And then I'm stretching by 2. Remember we talked about we're multiplying our original y value by 2. So from that new endpoint, we're doing 1, 2, 4, 4, and 9, 6. So there's our new square root graph. Your domain, look at the x-axis. That x value of that endpoint is -1 and it's everything to the right. So x would need to be greater than or equal to -1. Your y value of that endpoint is -3 and it's everything above. So y would need to be greater than or equal to -3. Alright, so now we're going to write the equation. So we are starting with f of x equals square root of x. And then we're going to read the transformations and find our new equation. Remember that you always want to have f of x or g of x, h of x, or y equals on all of them. Okay, we're shrinking by a factor of 0.5, so I'll just write 1/2, or you can write 0.5 as your a. And then you're shifting 3 units up. So you should have a square root of x, because that's what we're starting with. You're shifting up, so that needs to go on the outside of the square root, plus 3. Okay, so 14 reflects across the x-axis, that's negative. Stretch by a factor of 3, shifting 1 unit down. So we have a square root of x, and then again on the outside it should be -1. If it says left or right, that should go under your square root. Alright, last one. We need to check our endpoint. That's normally at 0, 0. So notice it went to the left 2 and up 2. And then also it's decreasing from left to right, which would mean there is a reflection. Check your points. 1, it would be -1 because of the reflection. 4, -2 because of the reflection, and those are the correct points. So the reflection is the negative. We're going to the left, so under your square root you should have x plus 2. Make sure it stays under that square root. And then the plus 2 on the outside because you're going up. And that's it. Alright, so this is another type of function. We went over quadratic and we've gone over square root. Make sure that you fill in your square root parent function on your parent function chart.